Okay. We went through and explained what a geometric sequence is, and we realized that geometric sequences are just like exponential. All right, exponential patterns. And when we did that, we realized that we can create an equation where y equals a sub 0 b to the x power, and that is equivalent to, if we had a sub n, all right, equals a sub 0 to the r to the n power, all right, where our base is r, and we have our initial condition. We also wrote out a simpler value where we could go and say, okay, a sub n could also equal a to the first times r to the n minus 1, and that would be another equivalent expression. All right, so here what we're going to do is we're going to go through 3 examples of writing the nth term of geometric sequences. Okay, once again, geometric sequences are exponential. So without further ado, let's try this out. The first one we're given is a ratio, common ratio of e. All right, so that means we're multiplying e repeatedly. Okay, we've done that a lot in advanced algebra or precalculus, and we want to create now an nth term, the last term of this sequence, and an equation, explicit definition to help us figure it out. So to do that, we're given the first term and we're given the ratio. Well, since it's a ratio, we're going to have e to the n power, and what we can do is we can figure out our initial term, all right, or we can simply use this, and a lot of times I will simply just use this one because it's a lot easier. Okay, so given our first term, which is 1, I'm just going to plug 1, plug 1 in there, all right, and then we're going to just go n minus 1, and we have our answer. So it'll be a sub n equals e to the n minus 1, and that's it. If you wanted to write it the other way, what we can do is we can actually plug in, all right, a value in here, okay, and where we have a sub n equals a sub 0 e to the n, and then we plug in a point to figure out what a sub 0 is. All right, so we plug in our point, we have 1, so our point would be like 1, 1. So we go 1 equals a sub 0 e to the first power, all right, and a sub 0 is going to equal 1 over e. And so I could write this out right here as another equivalent expression. A sub n equals 1 over e times e to the n. All right, and that would be another one. All right, but that can be simplified once again into this right here that we just did. All right, so 2 different ways, all giving us the same answers. All right, which one is better? It doesn't matter. All right, well, let's try a harder one right here. And we're going to try to figure out this geometric. All right, now to figure this one out, we have a sub 2 equals negative 18, and we have a sub 5 equals 2/3. All right, 2/3. Now this is where you get a little tricky, because the key thing, just like when you have linears, you have to find the slope. For exponential, really the key thing that we want to find, all right, the number one thing that we want to do is we want to find the base first, the base, or the r, the common ratio. Now to figure out this common ratio, the ratio is always equal to some sort of the value preceding it. So a sub n over a sub n minus 1. Now, if you don't realize this, you can always take your second term over the first term, or the third term over the second term, and so on and so forth to help us figure this out. So here, what we have is actually we're going to take, well, 2 values. Well, we don't have our consecutive values, but I'm going to take the 5th term over the second term. Now, what we have then here is, and I'll explain this way as well, is that we have 2 values that are being multiplied repeatedly. Sorry about that. So what we have here is, if I write this out, what we have is our second term, which is equal to negative 18. And what's happening is, if I want to find my third term, what I'm going to do is I'm going to take, because it's geometric, we know that's being multiplied by common ratio. So the third term should be negative 18 times r, whatever that ratio is. Now, the 4th term is going to be, well, this previous term, which is the third term, times whatever r was again. So we're going to have negative 18 times r times r again. And then we find our fifth term should be, well, the fourth term times r as well. Now, if I simplify this, I have negative 18r squared. And so that should be, well, hopefully you realize, negative 18 times r cubed. Now, from here, we can do some values. Because looking at this right here, we realize that, okay, r from the second term to the fifth term, all right, if you notice that there are, how many times is r being multiplied? 3. How do you get that? Well, if you just take this value right here, 5, all right, and subtract 2, you get 3 right there, okay, which comes from 5 minus 2. So r cubed. So the fifth term has to equal negative 18 r cubed. Well, what's the fifth term? That is 2/3. So I'll plug that in there, and now we'll solve. I'm going to take 2 divided by 3 times negative 18, and I have r cubed. From here, what we're going to do is we're going to solve this. We're going to cancel this out, and it's going to turn into 9. And so I have 1 over 3 times negative 9. And what we have then is negative 1 over negative 27. And that equals r cubed. R then is going to equal the cube root, because we solve for r, the cube root of negative 1/27, which equals a ratio of negative 1/3. All right? So we have negative 1/3 is our ratio. So we set up our value. A sub n equals first term, all right, or whatever value here. Negative 1/3 then is our ratio to the n power. Then from here, we just need to plug in a point. So I'm going to take this point right here to solve for that. Okay, so I'll have the second term I'll plug in here, and it's going to equal negative 18 equals whatever our initial value is, negative 1/3, negative 2. And what do we get? That's going to turn into 1/9, a sub 0, equal negative 18. And then multiply negative 18 by 9, then it equals a sub 0. And what I have then is going to be, what is that? Think about this. All right, 9 times 8, which is 72. And 7, so it'll be negative 162. All right, so we have our final answer. Take that negative 162. I'll put it up here. That's a sub n. There we go. And that is our value. All right. So that is the answer for there. The final one that we have is we're going to be taking, starting with the third term, and we have to find, going to the fifth term is 64 over 27. So we want to find geometric sequence. Well, once again, we have to find the first, or the ratio. So if we think about this, our third term, once again, is 16 over 3. Our fourth term then is going to be 16 over 3 times r. And our fifth term is going to be 16 over 3 r squared, because we have to multiply r twice in order to get to the fifth term. So 64 over 27 has to equal 16 over 3 r squared. We're going to simplify this. Multiply both sides by 3/16. 64 over 27. That and that will cancel out, and this will turn to 9. And 16 goes into 64, I believe, very evenly. And that's going to give us a 4. So we have 4/9 equals r squared. So what is r going to equal? R is going to equal, we have to take the square root. Now, we don't bring the plus or minus because we're talking about only one ratio, and it's just going to be a positive ratio right there. But because we could have a negative ratio as well, but we'll just keep it positive. Okay, so r equals 2/3. All right, so from here, we have our ratio, which is 2/3. So we can take this, and I'll use green in this car. So a sub n equals a sub 0 2/3 in my ratio. We have to the n power. Find a sub 0, take a point. Let's use this first one. We use 3 and 16/3. Plug that in to solve for initial condition. All right, so we said 2/3. I said plug in the 3. And that's going to give me 16/3. And now I solve for a sub 0. We have 8 over 27 thirds, and then multiply both sides by 27 over 8 times 16 over 3, and equals a sub 0. Simplify this, cancel that 2 is a 9, cancel that 2 is a 2, and we have 18. That actually turned out pretty nice. Okay, so we take our new value, go back up on top, change it up, and we have a sub n equals 18 times 2/3, locks it in. There we have it, and that is our nth term. I'm going to move this up a little bit there so you can see. All right, so geometric sequences are exponential patterns. Okay, we can use either one of those to write an exponential sequence. All right, both are great models to help us figure it out. So this one I've used exclusively, but that one also is great. All right, and from right here, we have our example 1, all right, example 2, and example 3 of helping us identify how to do geometric sequences. All right, so that's what we have. Look for another tutorials explaining some more fascinating things of solid sequences in the series.